So up to this point, we've talked about the definition of the derivative, and we are going to continue on and do a brief review, an inclusive review of the definition and writing an equation of a line given specific information. So here, this expression that we're given is known as the difference quotient. Okay, and this difference quotient is used to evaluate the limit as h approaches 0. But as it's written right now, this is actually the way we find the slope for the secant line. So essentially, it is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. However, if we use it in this form, where this notation right here, f prime of x, represents the derivative, this is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, and this is essentially the slope of the tangent line. So this right here is the notation for the derivative, and it's the formula for the derivative of f with respect to x. So the domain of f prime still consists of all x values in the domain of the original function for which this limit will exist, and the process of finding the derivative is known as differentiation. Okay, so if we have to find an equation of a tangent line to this given function y is equal to f of x at some given value a, where a is any point on the graph, this is what you need to do. In the first step, if you're given the function and some x value, you want to evaluate f of a, meaning you want to find the y value. In step 2, you will find f prime of x and evaluate f prime of a, which is really the slope, okay, of the tangent line. Then what we want to do is substitute the value of the slope and the given point that we found into the point slope form of the line, which is y minus y sub 1 is equal to m times x minus x sub 1. So at this point, this is all a review of what we've done. Okay, and now you'll be given the information in different forms. So here it says, given that f of negative 4 is equal to 2 and f prime of negative 4 is equal to 8, we want to find an equation for the tangent line to the graph of this function at x equals negative 4. So up here it says that we need our point. So here we have a point. In different notation, this is basically saying that we have the point negative 4, 2. This prime right here means the derivative, which this whole piece means that we have the slope at negative 4 and it's equal to 8. So we're saying that m is equal to 8. So based on this process, we have enough information here. It's given to us. We just have to interpret what they gave us. We can write the equation of the line that's tangent to the curve at negative 4. So we would say y minus 2 is equal to 8 times x plus 4. This is your equation. You're done. Okay, in the next example, we are actually given a function, which is a rational function, and we need to find f prime of 2, and then the equation of the tangent line at x equals 2. So we have a lot more to do here. The first thing that we need to do, since we don't know the shortcut yet, and we have to use the definition of the derivative, we need to use the definition that is at the top by taking the limit as h approaches 0. So one thing we will need is f of x plus h. So what we need to do is plug in x plus h here. So this gives us negative 3 over x plus h minus 5. Okay. In addition to that, we also need to evaluate f of 2 because we'll need a point later on. So f of 2 is equal to negative 3 over 2 minus 5, which is negative 3 over negative 3, so that means my y value is 1. Okay, so here's my point. I have the point 2, 1, and we need to find the slope. So here we go. We've got the limit as h approaches 0 of f of x plus h, okay, I'll just write the whole thing out, minus f of x all over h, which is now equal to the limit as h approaches 0. Here is f of x plus h, so it's negative 3 over x plus 5, x plus h minus 5, minus f of x, which is this. So technically it's plus 3 over x minus 5, and all of this is over h. So even if I were to try direct substitution here, the function is undefined. So I need to simplify by multiplying and getting rid of this complex fraction. So I want to multiply by the least common denominator, which is going to be x plus h minus 5 times x minus 5 over the same thing. Okay, so when I do that, what I want to do is distribute here and rewrite. So I have the limit as h approaches 0. Okay, when I distribute, my x plus h minus 5 cancel, and you're left with negative 3 times x minus 5 in the top. Okay, plus my x minus 5 cancel, and I have 3 times x plus h minus 5 here. And then in the bottom, do not distribute anything. Leave this h and everything that follows. Okay, so I need to distribute. So we have the limit as h approaches 0 of negative 3x plus 15 plus 3x plus 3h minus 15 all over this crazy denominator. Okay, so basically rule of thumb is anything that doesn't have an h should cancel out, meaning I have a negative 3x and a positive 3x. Negative 15, positive 15, so there I am left with my 3h in the numerator. So when I rewrite it, I have the limit as h approaches 0 of 3h over this crazy denominator of h times x plus h minus 5 times x minus 5. Now I can cancel out my h's, and I've got the limit as h approaches 0 of 3 over x plus h minus 5 times x minus 5. So the whole point here is to try to use direct substitution where h is equal to 0. So what that means is I'm going to put 0 in right here. And when I do that, that h goes away, and I'm left with 3 over x minus 5 times x minus 5, or x minus 5 squared, which is f prime of x, which means I found the derivative. So that's what that is. This is our derivative. And what we want to use this for is to find the slope. More specifically, the slope at 2. So now I can use this. F prime of 2 is equal to 3 over 2 minus 5 squared. So this becomes 1/3, which is f prime of 2, which is my slope. So I need this to write the equation of the line that's tangent to the curve at 2. And earlier in the problem, I found my point, which was 2, 1, and I found that by plugging my x value into the original function. So now that I have everything that I need, I can write the equation of the line. So this would be y minus 1 is equal to 1/3 times x minus 2, which is exactly what they asked for.